So another tip and trick for SolidWorks is how do I get these mounts to move in the assembly and cycle without binding or breaking? The way that you do it is with these things called point features. So I'll show you an example. So this is a spherical bearing that I downloaded from McMaster, and its origin is right in the center of the sphere. So if you take the housing, which is supposed to rotate around the sphere, it also conveniently has an origin right in the center. When you put this into an assembly, so your housing is fixed, and then your sphere is mated center on center. If you mate the origins to each other, you can do a coincident mate on the origin, and you can say, don't align the axes. Then it will allow it to swivel. But this only works for a part like this, where the origin is in the center of the part. So I can still move the spherical bearing anywhere that I need to within the assembly. So that's great news. Let's say you're working with a rod end. Here's a rod end from McMaster, and the housing is fixed. But here's the issue with this model. The origin is down here, not in the center of the sphere. And then same story for the sphere. So if I mate these origins to each other and unselect align axes, now these parts are mated, but they're mated around the wrong point. So that's not going to work. So how do you get around that? Well, in SolidWorks, they have these really cool features under the reference geometry tab in the toolbar. So what I'll do is I'll find a plane, and then I'll select the cylinder and then make an axis. And that axis is now on the center of the sphere. So that's great. But now I need a point, which would simulate an origin mate. So there's another feature called point. And so I'm going to select one of the planes again and the axis that I just made, and that's going to put a point right in the center of the sphere. So that's what I always do on spherical bearings. And then if you do the same thing on the housing, I can make a coincidence mate here. It will default to not aligning the axes because it's just a point-to-point mate. And now the spherical bearing can swivel any way that it needs to. So that's how I get all these suspension components to mate with each other properly, where they're fully constrained, nothing's going to fly around, but none of the mates are going to break. I'm very fastidious about, I mean, you could call it OCD, but I don't like having rebuild errors in my parts or my assemblies, because SolidWorks makes it this really ugly brown color and I just hate it. And I know it's not, something's not right. It is possible usually to get it right.